Okay, so let's talk about distance formula between 2 points and circles. First of all, when we have an x and y axis and it divides up this plane into 4 quadrants, that's called the coordinate plane. And here is the horizontal axis, which is x, and here is the vertical axis, which is y. And the origin is where they intersect, and the coordinates of the origin are at 0, 0. This is the first quadrant, this is the second, this is the third, and that's the fourth quadrant. So how do we get the distance between 2 points? Well, let's say that I have just a random point here at x1, y1, and I've got another point up here at x2, y2, and I want to get that distance right there. Well, this distance right here is the difference in the x coordinates. So that distance is x2 minus x1, and this distance right here is the distance between the y coordinates, so that's y2 minus y1, and by the Pythagorean theorem, the hypotenuse squared is equal to the sum of the squares of the legs. And then if I want to get the distance, I actually take the square root of that. And that is the distance formula. So let's do an example with some real numbers. And it doesn't matter which point is x1, y1 and which point is x2, y2. Okay, but I'm just going to say that this is x1, y1, and this is x2, y2. So, difference in x squared is 8 minus 2 squared, plus difference in y squared, 5 minus 5 squared, which gives us the square root of 6 squared, which is 36, plus 0, which is 6. Now here's a little trick. If I visualize where these points are, they have the same y coordinate. So they're straight across horizontally, aren't they? This is at 2, 5, and this is at 8, 5, and it's like on a ruler. How do I get the difference between 8 and 2? I just subtract. So that would be a quick way. So always check and see if they have the same y coordinates or the same x coordinates. Then you don't have to use the distance formula. Okay, let's do it with these 2 points, and my distance is going to equal the square root of difference in x. Now this is 5 minus negative 1, so watch your negatives. That's going to be 5 plus 1, plus negative 3 minus 8 squared, and that's the square root of 36, plus, okay, that's negative 11 squared is 121. So I get the square root of, what is that, 157. So that is the distance between those 2 points. All right, so let's talk about circles. A circle is defined to be the set of points that are equidistant from a single point called the center. In other words, they all have the same distance, which we actually call the radius. Okay? And so if this is a point, let's say x1, y1, and this is the center, which we'll call hk. You know what? I don't want to do the ones. I want to do x and y. This could be any point on the circle x, comma, y. Okay, then applying the distance formula, r is equal to the square root of x minus h squared plus y minus k squared. And when we're talking about circles, we square both sides to get rid of that square root. And so this is called the general form of an equation of a circle. Okay? Now, it's got some important parts. r is right there. It's always being squared, so you have to square root it to get the actual radius. H and K are always being subtracted, and those are the coordinates of the center of the circle. So let's find the equation of the circle with center 4, -3, and radius 5. Okay, that's H, that's K, and that's R. So x minus h squared plus y minus a -3, so that's +3, watch out for that, squared, equals r squared. And don't forget to square your radius. That's it. Now let's go the other direction. If I have an equation, can I find the center and radius? Yes. Here is h, there is k, and that's r squared. So the center is at +8, +1, because remember h and k are always being subtracted, and the radius is the square root of this number, which would be 8.